Welcome to Elementary Python for CBSE. Today we are going to discuss about data structures. In this topic we will discuss about the concept of data structure and its requirement, different types of data structures like linear and non-linear data structures, static and dynamic data structures, different operations performed on data structures like insertion, deletion, traversal, searching, sorting, merging, etc. Discuss list as a linear data structure. Perform various data structure operations on list. We can see how stack can be implemented using a list and various data structure operations on a stack, queue, and various data structure operations on queue. Previous knowledge of data types, list indexing, etc. will be helpful. Data structure is a logical way of storing and organizing data in the memory so that it can be used efficiently and it gives optimal performance. We have discussed earlier that complexity focuses on selecting appropriate algorithm so as to improve the efficiency in terms of its running time. Selection of appropriate data structure will optimize the memory usage. Different data structures may be used for different applications. Data type refers to the set of values and valid operations that can be defined on them, whereas data structure refers to an implementation which defines way of storing, accessing and manipulating data in an efficient manner. Different types of data structures may broadly be classified as linear and non-linear data structures. In linear data structure, elements are organized and accessed sequentially one after another. For example, lists, stacks and queues. In non-linear data structure, elements need not be organized sequentially. They may have multi-level data structures as in case of a tree or may be organized arbitrarily as in case of a graph. Data structures may again be classified as static and dynamic. Static data structures have a fixed memory size. Their size need to be defined or declared beforehand, and once defined they cannot be resized. That means elements cannot be added or removed as and when needed, whereas dynamic data structure provides flexibility and facilitates change in size during runtime. Elements may be added or removed as and when needed. Some common data structures. The most common data structure is a list. It is a collection of data elements that can be accessed sequentially, or it's a linear data structure. Stacks, they are special data structures and can be implemented using list. They are known as LIFO list, that is last in first out list, where the last element added is the first to be removed. It is also a linear data structure. Queues are also special data structures known as FIFO or first in first out list. They can be implemented using list, where first element added is the first to be removed. This is also a linear data structure. A tree is a collection of nodes and edges with a hierarchical organization, so it's a non-linear data structure. Graphs, it's an arbitrary collection of nodes and edges. It is also a non-linear data structure. Some common operations that are performed on various data structures are insertion, which means addition of new element to the data structure; deletion, which means removing an element; traversal, processing all the elements of the data structure; searching, checking for presence of any particular element; sorting, organizing the elements in a particular way; merging, combine two similar type of data structures to form a new one. Let us now briefly discuss about lists. A list is a sequence of heterogeneous data elements enclosed within a pair of square brackets. They are represented by enclosing them within a pair of square brackets. A list is a mutable data type. That means the elements can be changed or the value of the elements can be changed. It is a linear data structure where elements can be accessed sequentially using their index. List can be created in different ways. An empty list can be created just by assigning a pair of square brackets or using the constructor method list. Similarly, we can create any list by enclosing any number of items or elements within a pair of parentheses, as we have created here. Here num is a list of the numbers 1, 2, 3. We can also use the constructor method. For example, here we have created a list L1 by using the constructor method, passing a string Python as argument. So the list that will be created as PYTHON individual characters of the string. Here student is a list of heterogeneous data elements or heterogeneous list having a number, a string and a floating point number. We can also use the input method to enter elements for a list. However, they will be treated as strings. We can use the eval method for entering an entire list or accepting an entire list, as we have done here. Lists can be accessed using index, which specifies their position. Both forward and backward indexing is used. Forward indexing starts with index 0 to n-1, whereas backward indexing starts with -1 and is up to -n, where n represents the number of elements. For example, let us consider a list of vowels A, E, I, O, U. Here the forward indexing will be from 0 to 4. So A is having an index 0, or we can say the element at index 0 is A, element at index 1 is E, element at index 2 is I, element at index 3 is O, and element at index 4 is U. Similarly, backward indexing starts with -1 and it ranges to -5. So element at index -1 is U, element at index -2 is O, element at index -3 is I, at -4 is E, and at -5 is A. So we can access element using that index. Thank you.